Guys, welcome to my channel. My name is Danny. So in today's lesson, we're going to talk about streams in node.js. So as you already know, node.js has two parts. One is Google V8 engine, and the other is libuv. So libuv is just like, a event-driven loop, and Google V8 engine just like an interpreter of your JavaScript. So I've decided to start off with streams because when I take a look at the streams, I saw there are a lot of advantages of streams. So let's start off with streams. Without further ado, let's get started. So here's the agenda. So I just want to talk about the definition. So, and why we use streams. Because when it comes to streams, we have a lot of concepts or definition from different languages. For example, C++ has their own streams, and Node.js has a streams, and Java also had their own streams. But the stream, when it comes to in terms of the definitions of streams, I think it is pretty much the same. So we just start by talking about the definition, and next one we're gonna talk about four types of streams, one by one, for readable, writable, and duplex and transform streams. And every type is, I'm gonna break it into two parts. One is for if you are a consumer, how to use readable, writable, and duplex, four types of streams. And the second part is if you want to implement your own streams or just create a child class inherited from four different type of streams. So it's just, as shown from, or as said from Node.js official guide, they just break it into two parts. One is consumer, one is implementer. So I just follow this rules to break it into two parts. And also I'm going to talk about pipes, just connect one, for example, a readable stream onto the writable stream, and just kind of like a pipe hook into another one. And so every type, you just think of it as a span. So you can pipe many spans, so to build up a whole system. And last one is the miscellaneous, where it just so let's talk about definition. So what is a stream? So streams, there are a lot of definitions, and I found, and I think this definition shown here is pretty much the precise one, and streams are objects that let you read data from. So read data from a source or write data to a destination in a continuous way or continuous fashion. So there's a couple points we can notice. So if you talk about because the stream is objects, so they have their own property, they have their own methods, and also there's some internal for like this. The stream has their own internal data structure, so called a buffer or internal buffer. So if there's a readable stream, you can just use it to read data from the source. Source and destination means sometimes we call it underlying resources. For example, we just get into that, get into underlying resources in a couple slides. So here I just give you a rough definition here. So let's break it down to just here's a image or illustrated here. So stream, just if you look at the stream, so I just here just imagine that we have a bulk of data. We have a very big, very large data. And if you want to read this data, for example, with 100 megabytes or 400 megabytes or even larger than that. So if you don't use a stream technology or stream structure, you just pull it in as a whole, and you have to store the whole data, for example, 400 bytes in your internal infrastructure or node memory. So a very big data or a corresponding memory has been allocated within the node.js memory. So that's not very efficient, and also kind of like waste a lot of memory. So just alternatively, or here's an alternative way we can just chop a large data into the small chunks, like here we have. So break it into the many chunks, and the many chunks is like becoming a flow into your stream system. Here's your stream system. So for example, these chunks just flowing into your buffer. So because this chunks is pretty tiny little, so you don't have to have a very big buffer. So another way, so you can at this point you can notice that using stream, you can reach a space efficiency, where it is a space efficient technology because you chop it down to the chunks, so you don't have to have a very big memory block. Another things I want to mention that when the chunks flows into your system, your streams, for example, and at the same time, almost at the same time, and your processor can deal with this the separate chunks, and that means you can reach a time efficiency, because as the chunks flowing into your buffer, and then at the same time your processing just started to manipulate these chunks. So they really helps us to have a time efficiency. So another advantage of using stream is composability, because as I said, you can pipe many streams one by one. So every span, you can pipe many streams in a row, and every span or every stream just has their own function. For example, this readable, this transform, this another transform. So for example, the second span, just for example, encryption function can be used in this this stream. Help you transform some of the data into encrypted data, and flowing into the next one. For the next one, you just want to do a comparison, for example. So you just fulfill the comparison in the third stream, and so on and so forth. So kind of like connect different functions within the whole chain of streams. So that's a type, that's a pipe. So I think you're pretty familiar with pipe, because a Linux command, if when you look at the Linux command, there's always pipe or dash. Pipe your input into output, like that. The things the point is the same. So that's the three advantage for using streams. They provide us space efficiency, time efficiency, and composability. So here we have a little snippet to help you understand the time efficiency and space efficiency. So I just zoom in a little bit and just give you an implementation or sorry, the explanation of a pretty simple simple one. So if first part, I just want to show you or demonstrate how streams can do the space efficiency. So what I mean space efficiency, that means that they take up less memory space. So I just already pulled up active monitor. So, and monitoring memory. And here I use chance as a third-party library and create a random string with specific size. And that means for this function we don't use I don't use any function chance function. So here is just read existing file. The file is 100 byte, 100 megabytes. So we just read this file using a file system, FS module. Just read this file. Kind of like we just want to bring a very big data, 100 megabytes data, a big data into the node system. So and try to grab a real-time memory. So that's just a read large file and console log data to string. This here's this block, and I just run it. Oh, sorry, I just just run. As you can see, the string flow just you know, and we can see this 400 bytes. So this program takes up 400 bytes, right? 400 byte memory for this memory. So it just because this file is pretty big, so it just Control C to interrupt it. Control C. C. Oh, okay, the process finished. So just grab this memory size is roughly 400 megabytes. So then we just comment out this block and try to use a stream for reading this large file and do the same thing. For example, here we just invoke fs create read stream from we just create read stream from this file, the same file, and return an src source stream, and we give it a event handler for data event, the data event, and then we just this is callback and just or handler just console log the same thing. That's the same function. We just want to console log these many chunks, and also I just add a end event, add a callback for the event end. So it's pretty simple, and just as a comparison with the previous one, and just we just take a look at the memory occupation. Okay, sorry, just then we just run it. Also, okay, it's the data is flowing, and we can just see the memory is 23 megabytes. So it's a huge difference on space efficiency or space occupation. So it's a 22 is very stable. It's 22 because they just they don't you know, the node does not have to you know, the requires more memory. So let's just finish this. See, or just press the button. Okay, we just press the button. Okay. Second things we want to demonstrate to you is a time efficiency. That means we have two different snippets and with same function, and just we just watch their finishing time. Let's just comment out this previous one, and use this. Let me check this. Here I use a chance to create a random string with specific bytes. With here is in this case a 16K byte, and we have async await if functions here. Just console time. I just wanna grab the time, so the whole process time. So it just use the console time at the start and the console time end at the end. And here is file system dot open fs open, just open the test dot tst. An existing file with the flag w is right, and we just use fs system fs.writeSync to write our random string derived from the chance string, this one, or augmented string. So just write into the sync, write with the fs.writeSync, and it just passed in the file descriptor and the buffer. Buffer is derived from this chance string, the random string. I just add this one. Let me just 16 megabytes. So I just try to write one time with size of 16 mega. So without using streams. So just we can just look at the whole process. Here we just we don't need to use this. Just right here. So you can see the whole process time is 34 millisecond. I'll run it again, just in case something. So 33. 34, 33, right? So I just try to remember this data, and we just comment out this block, and we just enable this and disable this, because here we use promises. So fs promises as fs, so just pretty much the same function, but here we're using stream. So we just have a for circulation iteration, so for 1000 times. So it just delete three zeros, because 16K times 1000 is 16 megabyte, the same size. We just we want to create other function or logic. They're pretty much the same, and also use this buffer derived from the chance. So we just stream write this buffer to our destination, which is test.txt, and we just work out a time, the whole processing time. So this time I just press the run button. You can see this is 19.163 millisecond. I just try it again, 22. So again, 19. So 19 versus 30, 33, 34. So you can see the difference on time efficiency or processing, speed of processing. So that's the two advantages I just gave you, or demonstrated. So that's everything for today, and hope you enjoy it. Hope you just observe the whole differences, and just realize the advantage of using streams. Thank you.